Hi everybody, welcome to Unit 5, Video 3. If you don't have your Unit 5 notes packets out, please get it now. All right, so we are on page 4 of the notes on number 3, where it says, I can simplify expressions involving sum of radicals. So what we need to do here, before we can add these, is we have to simplify them completely. Rad 6 is already simplified. There's no perfect square factor that you can take out. So I'm just going to bring this one down. But the square root of 54, that can be simplified. The perfect square factor is 9 times 6. So when I simplify this, here I'm just going to bring rad 6 down. And then the square root of 9 is going to give me 3. I can't do anything with rad 6. But now these two, now they're like terms. They're like radicals. They both have rad 6. Remember here, there's a 1 in front of the radical 6. So I say 1 rad 6 plus 3 rad 6 is going to give me 4 rad 6. So this is your simplified answer. All right, so for this one, I'm going to start by adding these two together. So I'm going to get 2 rad 18, because remember, again, there's that 1 in front of here. But now I can simplify 18. So I have 2 rad 18 is 9 times 2. So when I take the 9, the square root of 9, I'm going to get 2 times 3 rad 2, which is going to simplify to 6 rad 2. So there's my simplified answer. Okay, so remember, you can't combine them until they are like radicals. So let's go ahead and take a look at this next one. So the perfect square factor of 45 is 9 times 5. And here for 20, I can break it apart into 4 times 5. So now I'm going to simplify it. So the square root of 9 is going to give me 3. So I have 3 rad 5. Plus here, the square root of 4 is 2. So I can take that out of radical. So I have 2 rad 5. So then when I add these together, 3 rad 5 plus 2 rad 5 is going to give me 5 rad 5. Okay, so for number 4, we have to simplify it. So this one is saying the cube root of 45. Well, there is no perfect cube factor of 45, so I just need to leave it alone. So I'm going to just rewrite it as the cube root of 45 here. 2 rad 3 is already simplified, so I'm just going to rewrite it. But 27 does have a perfect square factor. So I'm going to say 3, and then I'm going to simplify this. 27 can be 9 times 3. So again, I'm just bringing down the cube root of 45 here, plus 2 rad 3. And then this last term I need to simplify. So I have plus 3 times the square root of 9 is going to give me 3. And I still have this rad 3 here. So when I simplify this, 3 times 3. So again, I'm just going to bring this down. The cube root of 45 plus 2 rad 3 plus 9 rad 3. And now I can combine my like terms, which are the 2 rad 3 and the 9 rad 3. So over here, I get the cube root of 45 plus 11 rad 3. So this is my answer. So again, remember, in between the 3 and the radical sign, there's an implied multiplication sign. So that's why I multiplied 3 times 3. All right, so let's take a look at number 5. So number 5 here, again, I want to simplify if possible. So I'm going to get 3 parentheses 9 times 2 would give me 18. So then when I simplify this, I get 3 times 3 rad 2, which is going to give me 9 rad 2. This middle term here, negative 2 rad 6, it's already simplified. So I'm just going to bring it down here. And same thing with this positive 3 rad 6, it's already simplified. But these are like radicals, so I can combine them. So negative 2 rad 6 plus 3 rad 6 will give me a positive 1 rad 6. You could write the 1. I know that it's implied, so I'm just going to leave it. And rad 2 and rad 6 are not like terms, so I can't combine it. So I'm just going to bring it down. And so then this is my simplified answer. All right. So the next one is saying the cube root of 3 and the cube root of 2. Well, I can't take the cube root of 3 and I can't take the cube root of 2. So in this case, it's already simplified. So there's nothing you can do there. So you could write already simplified or not possible. There's nothing else to combine. So you can just leave it alone. All right, for the next one, again, you want to simplify first and then see if you have like radicals. So let's go ahead and simplify here. So we have the square root of 8 times x cubed. So remember, you want to break it up into perfect square factors. So 8 is 4 times 2. And x cubed I can break up into x squared times x to the first. So then when I simplify that, the square root of 4 is 2. The square root of x squared is going to leave me with x. And then I'm left with rad 2x here. For this middle term, I'm going to bring down the minus sign, the x, and I'm going to also break this apart. This is 9 times 2 times x. So when I take the square root of 9, I'm left with minus 3x, because remember you multiply the x and the 3, and then I have rad 2x. So now we can say 2x rad 2x minus 3x rad 2x is going to leave us with negative x rad 2x. You could put the 1 if you wanted to, negative 1x. All right, so here, let's go ahead and again, we gotta simplify first. So remember, x cubed is saying x squared times x to the first times y. So when I simplify this, the square root of x squared, so I'm gonna get x rad xy. And then here, when I simplify, I can think of this as x times y squared times y to the first. So then this can come out of radical. So I have plus y rad xy. So now when you write this, we're going to add the coefficients together. So you want to think of it as parentheses x plus y rad xy. Okay, so here's your answer. All right, so let's go to the next page. So on the next page here, we need to, before we can add these together, again, we have to simplify what we can, and remember, we have to rationalize the denominator. But first, I'm going to simplify this numerator. So I'm going to think of this as 27 is same as the square root of 9 times 3. So I'm going to get 3 rad 3 over 5. Rad 5. And minus, I'm going to break this into rad 3 over rad 5. So I'm going to rationalize the denominator here. So remember, I need to multiply rad 5 to the top and to the bottom. So here, same thing on this right hand side, because I'm not allowed to have a radical in the denominator. So when I do that, I'm going to get 3 rad 15 over 5. On this right hand side, I'm going to get minus rad 15 over 5. And so now remember the rules of adding or subtracting fractions. They have to have a common denominator. These ones have the common denominator of 5. So I can go ahead and add the numerators. So 3 rad 15 minus 1 rad 15 leaves me with 2 rad 15 over 5. Okay, so same thing here. You want to simplify if you can. There's nothing to simplify, so then I need to start by rationalizing my denominators. So here, you're going to want to, oh, my pen. You can say, okay, so we can say rad 2 over rad 3 plus rad 3 over rad 2. And then I'm going to rationalize the denominator, so I'm going to multiply rad 3 to the top and to the bottom here. So in this one, I'm going to get rad 6 over 3. On this side, I need to rationalize, so I have to multiply rad 2 to the top and the bottom. So I get plus 6 over, or sorry, rad 6 over 2. But now again, remember the rules of adding fractions is they have to have a common denominator. So I have 3 and 2. So in order to make them have a common denominator, which I want to be 6, I'd have to multiply 2 to the top and to the bottom here, which is going to give me 2 rad 6 over 6. And then on this side, I would have to multiply 3 to the top and the bottom. So this is going to give me plus 3 rad 6 over 6. So now, again, the rules of adding fractions, common denominator. Now that they have a common denominator, I can add their numerators. So then that's going to give me over here 5 rad 6 over 6. Okay, so let's go to the next problem. So what we need to do here, again, is you want to simplify if possible. If there's nothing to simplify, then you need to make sure that you are rationalizing your denominator. So here, first, the square root of 4, I can simplify it to 2, and I can leave this as rad 3 on the bottom. So here I have plus rad 6 and rad 2, those can be simplified. Rad 6 divided by 2 would leave me with rad 3 over 1. And here, same thing, rad 2 and rad 6, I can reduce those. So I'm left with minus 4 over rad 3, because 2 and 6, I can factor 2 out of both of them. So then, once I do that, I'm going to be left with rationalizing the denominator, because I can't add them or subtract them until I have this radical out of the denominator. So on this first term, I need to multiply rad 3 to the numerator and the denominator. So that gives me 2 rad 3 over 3. Plus here, rad 3 over 1. There's nothing to do, so I'm just going to rewrite it. And on this one, I have to multiply rad 3 to the top and to the bottom. So I get minus 4 rad 3 over 3. Again, the rules of adding fractions or subtracting fractions, the common denominator. So the common denominator is going to be 3. So the first term already has 3 in the denominator, so I'm just going to rewrite it. The middle term, I'd have to multiply 3 to the top and to the bottom. So I'm going to get plus 3 rad 3 over 3. And the last term, I didn't have to do anything because it already had 3 in the bottom. So now I can combine like terms. So the numerators, so all have rad 3, so they're like radicals. So I say 2 rad 3 plus 3 rad 3 would give me 5 rad 3 minus 4 rad 3 would give me 1 rad 3 over 3. So there's your answer. All right, so the next problem here, again, we need to simplify if possible. So there's nothing to simplify here. So remember this one, there's over 1. So if you want to think about it as the cube root of 4 over 1, you can. Here, this one I need to rationalize and simplify. So the cube root of 1 is just 1. And the cube root of 2, I need to get this radical out of the denominator. And remember, now I'm looking for a perfect cube, not a square, so I can't just multiply it by itself. So what I need to multiply it by here is I need to multiply the cube root of 4, because remember, you're looking for a perfect cube. So I'm going to rewrite this first term. So the cube root of 4, okay, so I have the cube root of 4 over 1, plus on the numerator here, 1 times the cube root of 4 is going to give me the cube root of, the cube root of 4. Okay, so I get the cube root of 4 over the cube root of 8. And remember, the cube root of 8, that's a perfect cube. So I'm just going to rewrite this. The cube root of 4 over 1 plus the cube root of 4 over 2. Because remember, 8 is a perfect cube. 2 times 2 times 2 would give you 8. All right, so now that I have this, remember to add, I need the common denominator. So I need to multiply 2 to the top and the bottom here to get that common denominator so I can add them together. So that's going to give me, when I do that on this side, I'm going to get 2 cube root of 4 over 2 plus the cube root of 4 over 2. So when I add those together, that's going to give me 3 cube root of 4 over 2. Okay, so now let's go to the next one here. All right, so what you want to do here is remember this denominator of 2, and it's going to apply to both if you split up the expression. So you can think of it like this, as rad 10 over rad 2. Hold on. Okay, sorry, my pen isn't working that well. So I split it up into rad 10 over 2 plus rad 250 over rad 2. So then, right now, I can reduce them. So rad 10 over rad 2 would simplify to radical 5. Here, I bring down the plus sign, and rad 250 divided by rad 2 would leave me with the square root of 125. So now I can simplify rad 5, I'm going to leave alone for right now. And then here I need to find the biggest perfect square factor of rad 125. So I'm going to get 25 times 5. So then when I bring this, I get rad 5 plus 5 rad 5. So then I can add those together, which gives me 6 rad 5. Okay, so when you do something like this next one, you're going to distribute here. Since these are both under radical, you can multiply them together. So 2 times 8 is going to give me 16. So the square root is 16. Plus, when I multiply these both underneath the radical, I'm going to get the square root of 20. So now that I've done that, I'm going to simplify. So the square root of 16 is going to leave me with 4. Plus, I can break rad 20 into, I can think about it as 4 times 5. Okay, so then I get 4 plus 2 rad 5. And now at this point, these are not like radicals. I have 4 and then 2 rad 5, so I can't do anything, so I leave them as an expression. So this whole thing is my answer here. Okay, so if we go to our next problem, same thing, we need to distribute. So we get rad 15 times rad 3, which is going to give us the square root of 45. I'm going to bring down the plus. Now remember, the coefficient of radical 15 is a 1. So you're multiplying the 1 times the 2 together, which is going to give you 2. And then you multiply what you have underneath the radicals here. So 15 times 5 is going to give me 75. All right, so now we need to say this can break into, I can think about it as 9 times 5 plus 2 rad 25 times 3. So then when I simplify it, the square root of 9, I'm left with 3 rad 3 plus 2 times, this would be 5 rad 3. So then 3 rad 3 plus 10 rad 3. So when I combine those together, 3 rad 3 plus 10 rad 3 gives me 13 rad 3. So then there's my answer. Okay, so this last one, why don't you go ahead and try to do it? So remember, you're distributing, the coefficient multiplies with the coefficient, and what's underneath the radical multiplies what's underneath the radical. So distribute and see if you can simplify completely. So pause the video and try it. Okay, so let's see how you did. So when you distribute here, you get 2 rad 144 minus 10 rad 36. So then the square root of 144 is 12. So I get 2 times 12, which gives me 24. On the right-hand side, I get 10 times the square root of 36, which is 6. So I get 60. So 24 minus 60 gave me negative 36. All right, thanks for watching the video.